So here's another probability problem. It says that the mean is equal to 75. So in statistics, we use the Greek letter mu to be the mean. So mu equals 75. And the standard deviation, which is a measure of how much variation there is 15 points. And we use sigma, the lowercase sigma, as standard deviation, so it equals 15. And then this is going to be the score that's asked about, and it's actually saying at least 90. So we're going to find the probability that x is at least 90. Okay, so with the normal distribution, it looks like this. So there's this nice bell-shaped curve or normal distribution, and the mean goes in the middle. And then the function that creates that looks like this. So 1 divided by the standard deviation, which is 15, and then obviously the square root of 2 pi. Then there's going to be e to the negative, and then this is going to be our variable x. This needs to be the 75, and then it's divided by 2 times the 15 squared. So for the moment, it might look like, oh my goodness, do I really want to integrate this thing? But it's going to turn out to be not too bad at all. So first of all, I need to substitute the numbers. So the standard deviation is 15. And then the square root of 2 pi. And then it's e. And then x is the variable. And then minus the mean is 75. That's squared and divided by 2 times the standard deviation is squared. And when you graph this, it's going to look just like that. Okay, so the good news is that because this is basically e to the x squared, so if you ignore all of the extra numbers in here, we're basically going to need to integrate e to the negative x squared. And the good news is there is no antiderivative for this. So you can either wait until the end of chapter 11 and we'll do an infinite series for it, or we could use the calculator. So we use the calculator. So first of all, I need to type this into the calculator. And go to y equals, and so there's a 1 divided by, and then put that in parentheses, of 15 and a square root of 2 pi. All right, so that's in parentheses, so that means that whole thing is in the denominator. And then we need the e function, and then it's got negative and x minus 75, and then that's squared, and then it's divided by 2 times 15 squared. And then all of this is in the exponent. All of this is in the exponent of the e function. So now if I change the window and I center it around 75, so let's say go from, well, let's go from like 50 to 100. And this function is not going to be very tall because in total, the total area is 1. So it's not going to be very tall. I'm going to have it just go from 0 to 1 and see if I can see the graph. So yeah, it's actually much shorter than I thought. So if I trace it, I can see that the y value is only a 0.027. So if I have this go up to 0.0, so it says 0.27. So if I go to 0.3, I should be able to see the graph better. So now it's making that normal distribution. And then the question said, sorry, right here. The question said that it's at least a 90. So we need to integrate from 90 to forever. Well, right now, I think I only have it going out to something like 100. So if I'm going to go from 90 to forever, then I'll just put a bigger number. Like, what if you go 0 to 200? And then there's the normal distribution. And so now we can go second, calculate, and do number 7 to integrate from 90. And then technically we're supposed to go to forever. But as you can see back over here, there really isn't much of the graph left. It's not going to add that much if I go to 200. And it says that the answer is, the calculator's still thinking. So it's a 0.159 or 15.9%. So then using the calculator, it basically said right here in the middle is 75. Sorry, let me zoom back out. And then we integrated from 90 on. And then this area was 0.159 or 15.9%. So basically getting at least 90 on the exam is an A. So what percent of the class should get an A? In theory, 15.9%.